So here you understand.
No.
You don't understand here?
I understand it, but I mean, I don't understand the next row.
So that's equal to 0.
Okay.
So the denominator need to be 0. For example, I give you x over 100 is 0. X is 0, right? So we know here is not 0, so here need to be 0.
Okay.
And then that is 120
Okay.
minus 100
Okay.
plus 20x, that is 0.
Okay.
And then 20 plus 20x is 0. We just move it there, x is negative 1. Let me know which step.
How you got -1?
So this step, you know,
Yeah, -20. I get that step.
20x equal to negative 20, right? 20x equal to negative 20.
-20, I get that part.
And then you divide.
Okay, I
by
get
20.
it. Yeah, I didn't see it at
Both
first.
sides.
I didn't see that at first.
Yeah.
My mind moves slow.
It's fine.
So x is
It's
-1.
Yeah,
Now we have to find y.
right. But it's the same way of calculation. Y, center of mass will be 40 times 4 plus 50 times negative 6 plus 20, we don't know the y. The denominator is 40 plus 50 plus 20, and we know that is 0 because it's in origin, right? Again, here need to be 0. And then it's 160 minus 300, 50 times 6, plus 20 times y. That is 0. And then that is 140, right? Plus 20y is equal to 0. Move this to the right.
Right.
20y equal to 140. And y equal to 7.
Let's see.
Yeah. So the next question is similar. A 2-kilogram particle have a velocity of 4, and in the positive x direction, 3-kilogram particle has a velocity of 5 in the positive y direction. What's the speed of the center of mass of the 2-particle system? So it's the same thing as center of mass. The speed of the center of mass is equal to VA plus B, of course that's along x plus, and then divided by the mass. Right? That's the equation we got. So for this question, the speed of the center of mass along x is the 2 kilogram is 4 meters per second. The 3 kilogram only move along y, so it's 0, divided by 2 plus 3. So it's 8 over 5. kilogram no velocity along y times 0 plus 3 kilogram 5 meter per second along y. So it's 15 divided by 5, that is 3. Okay. So and then the question is, what the speed of the center of mass? It will be Vx squared plus Vy squared. Okay. And if you calculate it, it will be 3.4 meter per second.
Okay.
Last one. A 0.28 kilogram stone you throw rises 34.3 meter in the air. The magnitude of the impulse of the stone received from your hand while being thrown is what? So it asks you the impulse, which will be equal to the mass times the delta weight, right? We know the initial velocity is 0 because it was at rest, and then you gave a speed to the stone. So delta weight will be actually v, because the initial is 0. So Vf minus 0, so delta weight actually is the Vf, the final velocity. The question is asking that. Actually, this question turns into, we don't know the initial velocity, but we know the maximum height it can go to is 34.3 meter. So what's the initial velocity? Actually, yesterday I taught you one way to calculate. Actually, the fastest way to calculate is using the potential energy, the conservation of the energy. At the beginning, it will be V squared, right? That's all the energy it has. It will be equal to the potential energy here, but here the velocity is 0 because it's reached the maximum. Right? So we know the mass is 0.28. We don't know the velocity. 0.28, 9.8. The height is 34.3. Right? If you calculate the velocity, you got 25.9 meter per second. You understand here?
Mm-hmm.
So we know that the initial velocity for this stone, but what impulse you need to give to the stone to have this velocity? It will be mass times the velocity, which is 0.28 times 25.9, and then you got 6.26. So it's C for the